Welcome back. So this part of the lesson is going to be actually how to use Python. We can use Python in many different ways, but today, or I mean, in this part, I will show you using the command prompt. You can just select it here, or maybe you can write CMD over here, and then you can open the command prompt. Yeah, maybe some people. Or another way to open, you can all click over here. I think you can open the command prompt. Where is my command prompt? Oh, it's only the git bash. Maybe I think some of you should have, but since I have git, I think the git bash is something I should see is the git bash. This is also the same, but you may not have git. So let's just go to CMD and open the command prompt. This command prompt allows us to write commands. Yeah, it's the window version but I think some of you might know, but you don't have to also know how to use the command prompt. What you should know is just opening the command prompt. So now this Python is when I'm writing Python, actually it's like a command or to open the Python that we installed a while ago. Now I can see that Python 3.10.0 has been actually installed, and it's the latest version that has been released on October 4, 2021, as you can see here. And then, like, for instance, if we want to work on Python, or if we want to ask Python to do some mathematics for us, let's ask Python to add two numbers, 1 and 2. What do you think the result will be? No?
It should be 3.
Yes. And how about if we ask also Python to subtract numbers 2 minus 1, and everybody expected that 1, and that's what I expect too. How about if we ask Python also to multiply numbers? As you can see now, we use the plus sign for addition, this the minus sign for subtraction, this the star or the asterisk for multiplication. Okay, it's a bit different. And the reason why I'm using also space, it's for readability purpose. It's so easy to read, right? I can just do this 1 plus 2 and it just give me the same thing. No difference, 1 plus 2, but this looks good for the eyes, right? It's well spaced and it's so nice. And as I showed you, 3 times 2, it should be 6, or 2 times 3, it's 6, right? Just commutative property, right? You can change the place and you should get the same value for addition, and the multiplication is the same. How about if I want to divide numbers? If I divide 3 by 2, I think you will expect 1.5. And how about sometimes like multiplying numbers? 3 by 3 is 9, right? How about again by 3? 27, again by 3. I think it's going to be 81. No. 3 by 3, 9, and by 3, 27, and then by 3 is going to be 81. Yeah. So sometimes writing this is tedious and long. Then how about if you want to write 2 times 2 times 2 times 2 times. If you do this 10 times or maybe 20 times, it's tiring, right? So we have a shortcut, actually, this. So this means, for instance, to the power of 5. So whenever we use this 2 star, means actually we are multiplying 2 5 times. So I'm expecting, maybe I think first I have to show you this. To the power of 3, you are expecting 8. So it should be 8. To the power of 4, and this is 16. To the power of 5 and 32 to the power of 10 actually gives you 1024. I think by now, so 3 to the power of 4, this give us 81. Yeah. Now let's do modulus. Sometimes we want to know the remainder of something. For instance, when we divide 3 divided by 2, now the percent sign is not acting like a division because we have division this sign, but we call this symbol modulus, and it gave us the remainder when we divide two numbers. What's the remainder when we divide 3 by 2? Yeah, please. What's the remainder when you divide 3 by 2?
5.
1.5 it should be, shouldn't it?
But the remainder.
1, you mean 1?
1. Yeah, the remainder is 1. As you can see. How about 5 divided by 3? What's the remainder?
2.
Yes, great. And 9 divided by 5, what's the remainder?
4.
4, great.
4, yeah.
11 divided by 6, what's the remainder?
4. Again 4.
Yes, 4. 9 divided by 3, what's the remainder?
0.
0, because there's nothing, so it's 0. Great, now you got how to calculate remainder. It's very important. For instance, to know if a number is divisible or not, if you divide something, for instance, by 2, and if the remainder is 0, that means it's divisible by 2, right? Is 9 divisible by 2? No, because the remainder is 1. Okay, now let me try. By 2. 10 divided by 2, let's see the remainder. The remainder is 0, so that means it's divisible. So we can check divisibility of something. For instance, 39 divisible by divided by 3. If I get a 0, then I will decide that this 39 is divisible by 13. Yeah, great. So you will use it like to check some divisibility or some condition. It's very important. Now let's talk about floor division. Sometimes we don't care about the remainder, but we just want to know how many times it can be divided. Okay, if I want to say 3 divided by 2, and that without the remainder, what will be the value? So I can use these two symbols to get the quotient. We call it the quotient, but we don't care the remainder. 1. Great. 9 divisible by 4. What would be the value?
2.
Yeah, 2. And there, yeah, 2. And 7 floor division 2.
3.
3. Yeah. Now, guys, you managed to learn the arithmetic operation. You have learned how to add numbers. It's so easy, right? You learned how to subtract numbers. You learned how to multiply numbers, and you learned how to divide numbers, and you learned exponential power, the base and the power, to the power of 3, 8 to the power of 4, 16 to the power of 5, 32, and to the power of 10, 1024. And we have, then we learned modulus, how to calculate the remainder. If we divide 3 by 2, actually the remainder will be 1. If we divide 5 by 3, the remainder will be 2. And if we divide 9 by 5, and the remainder will be 4, and then 10 by 6, 4. So yeah, that's what we learned. Again, we have learned here actually the floor division. The floor division means we just only care how many times it can be divided. We don't care about the remainders. 3 divided by 2, 1 times. 9 by 4, 2 times, the remainder will be 1. 7 by 2, 3 times, and the remainder will be 1. But we don't care for the remainder this time. Now maybe the last example, 8 divided by 5. What would be the floor division for this?
1.
1. Great. Guys, you have completed the arithmetics, and you learn also how to use the Python interactive shell. We call this Python interactive shell whenever we want to do some Python script. This is how we write. And we can leave also from this by just closing over here, just to make make yourself familiar. Just you can here CMD, and then you can write like Python, or just py is enough to open. And we call this the Python interactive shell. We don't write code all the time here. We use other code editors, but sometimes, you know, we come to here and taste some calculations or some code. We write just simple codes here, just for testing purpose. We don't really write code over here, but sometimes we just came over here and check if what we taught is right. So we use it for testing purpose, not for writing an application. Great. So this is how a Python interactive shell looks like. Some of you might be using this. I may, by just opening this, it's okay. But for some reason, I prefer to open this, the command prompt. Yeah, the command prompt for me to open. By the way, if you write just P, it also open for you, and exit, and you have to invoke it to get out from that. If you really want to just know only the version, Python version, will give you this Python version, and then it gives. But if you want to open the interactive shell, just Python, and then exit. Or you can just write py, also allows you just to open, and then just let's get out from that. And let me just leave also from this, the command prompt. And now I closed the command prompt. No problem with the command prompt. You can also just close it like this. Okay, great.